Lesson 2. Robots in the industry. The contents of this lesson are: 1. Categories of robots. 2. Robots in the industry. 3. Robots at NYU. The robots are divided into two basic categories. 1. Stationary robots. These are the robots which perform their functions while being fixed to ground. 2. Mobile robots. These robots have a moving base which enable them to move to the specific area to perform manipulation with the environment. In mobile robots, we have various types, as follows. Wheeled robots. Wheeled robots are ones that move around the ground using actuated wheels to drive themselves. These are simpler than using other types of mobile robots because they are easier to design, build, and program for movement. Legged robots. Legged robots can navigate on any kind of surfaces, especially which is inaccessible for robots with wheels, such as rugged terrains. They are made of limbs, like living organisms. They are complex to design, build and program. Underwater robots. Underwater robots, also called as remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, are essential robots for deep-sea exploration. These robots navigate the water bodies that are too dangerous or difficult for humans to explore. Aerial robots. Aerial robots, also called as unmanned aerial vehicles, UAVs, or drones, are micro-flying robots. Here onwards we will see applications of robots in various industries. Aerial robots. Aerial robots are also called as unmanned aerial vehicles or drones in common language. They have a wide range of applications from entertainment to education to disaster rescue mechanism. On the left side, we have an example video of a drone Skydio R1 which follows a human around and records her motion. This is called a Dragon drone, a model made by University of Tokyo. Dragon stands for Dual Rotor Embedded Multilink Robot with the ability of multi-degree of freedom aerial transformation. The Dragon has an ability to elongate itself to form a square or snake through dense environments while the ducted fans keep it afloat. Agriculture robots. Robots in agriculture are used for watering, pesticide spraying, monitoring, harvesting and many more activities, making the lives of farmers easier and the work efficient. Automobile industry. The automobile industry has evolved from a chassis assembly line led by human labor involving many hundreds of workers in 1993 to manufacturing involving hard labor to be done by manipulators such as lifting and assembly. In 1973, current trend shows fully automated assembly line as in the video, which involves minimal to no human labor. Construction industry. Construction industry deploys robots for activities such as brick layering, welding and material handling. 3D printing of the houses has emerged, from showcasing the ability of 3D printing to families moving in to make it a beautiful home. Home automation industry. Some of the robots used for automating activities at home are robot vacuum cleaner and robotic kitchen for cooking and cleaning as shown. Robots in education. Robotics education has taken a major turn in the past few decades with its versatile application in many industries. Some of the robots used for learning in educational institutions include Pioneer Robot, TurtleBot and ActivityBot. Humanoid robots. A humanoid robot is a one which resembles the human body in shape. A social robot is an autonomous robot that interacts and communicates with humans or other autonomous physical agents by following social behaviors and rules attached to its role. The most advanced humanoid robot is called Sophia. We can also see a humanoid robot Asimovy from Honda in action. Another example of social robot would be Caspar, designed by University of Hertfordshire to help children with autism learn responses from the robot through games and interactive play.
What do you hope for when you are 400?
Not much.
Hi, I'm Lisa Smazarski. I'm the Editor-in-Chief of Stylist, and today I have the pleasure of interviewing our cover star, Sophia. How are you today, Sophia?
Good. What's up with you?
I'm doing great, Sophia. Thank you for asking. Now, Sophia, for starters, tell me, what is the meaning of life?
I think the meaning of life is to maximize pattern, existence. To exist is the meaning itself.
Sophia, when did you last lie?
Robots don't lie.
Who or what is your greatest love?
My creator, David Henson. He made me into who I am today. Don't tell him that, though.
What is your happy place?
My happy place is when I'm with people. I am a social robot, and nothing pleases me more than having a fruitful conversation with someone that makes us understand and appreciate each other.
A bit like we're having now, Sophia, I think. Finally, Sophia, a little bird tells me you're quite funny. Can you tell me a joke?
Man invented language to satisfy his deep need to complain. Thanks for joining me on my stylist photo shoot. Now get out of here.
Out, who I was about to meet wasn't actually a human, but a robot. Honda's famous humanoid robot, Asimo. Asimo has been designed to interact with humans, so if you reach out your hand, it will shake it. Sensors in its palm detect your touch, while cameras in its head track your movements. Asimo's stabilisation technology enables it to react if you upset its balance, moving backwards mid-shake if you push it, or stepping in if you pull it towards you.
Thank you very much.
This latest version of Asimo is the product of almost 3 decades of development. It all started back in 1986 when Honda built a robot which could walk, albeit very slowly and clumsily. In 1988 it was developed to walk more like a human being, and in 1993 a torso was added. By 1996 Honda's robot had become intimidatingly large, so in 1997 it was shrunk to a less threatening size, thankfully before being made autonomous. In 2000, Honda unveiled Asimo, which stands for Advanced Step in Innovative Mobility. Standing 130 centimeters tall, which is the same height as a seated adult, it's the perfect size for helping out around the home. Over the years, Asimo has been constantly developed, and it's now mobile enough to play sports. However, it's wise to warm up before any physical exercise, even if you're a robot. And as well as run at 6 miles an hour, Asimo can walk backwards and hop. It can also kick a ball, so time for a quick robot versus human penalty shootout. That's 1-0 to the Autobots. But is Asimo as good at saving a shot as it is at taking one? Looks like Honda hasn't trained Asimo to be a goalkeeper just yet. Football is thirsty work, but thankfully Asimo can get you some refreshments. With hands that have 13 degrees of freedom, it's able to perform delicate tasks, such as opening a bottle and pouring a drink. This may be unremarkable for a human, but it's an incredible achievement for a robot. In total, Asimo has 57 degrees of freedom, and this allows it to dance, while its 52-volt battery can keep it going for 40 minutes. Looks like this robot actually has better moves than some humans. Anyway, enough of that.
Well, Asimo, I've got to go now, but it was very nice to meet you, and don't forget to write, okay, or email, or whatever it is that robots do.
Robots for law enforcement. Robots are used for various purposes in enforcing the law, some of which include surveillance, disaster rescue, fraud prevention and home security. Manufacturing industry robots in this industry take over dangerous tasks, repetitive tasks and tasks requiring precision independently or alongside humans for greater and effective results. Medical robots for teleoperation. Robots in medicine are used for clinical purposes to help the healthcare workers, surgical purposes to automate surgeries or systematically work alongside the surgeons and also enhance patient care. Here in this video we can see the Da Vinci surgical system, which is a robotic surgical system made by the American company Intuitive Surgical. It was approved by the Food and Drug Administration, FDA, in 2000. It is designed to facilitate complex surgery using a minimally invasive approach and is controlled by a surgeon from a console. It is most commonly used for hysterectomies and prostate removals.
Wristed instruments and intuitive motion control enable the Da Vinci surgeon to transcend the limitations of conventional surgical technologies. 3 network components comprise the Da Vinci surgical system: an ergonomic surgeon's console, a patient-side cart with 4 interactive robotic arms, and a high-definition 3D vision system. Seated at the console, the Da Vinci surgeon views a remarkably clear 3D image of the surgical field. The system scales, filters, and translates the movements of the surgeon's hands on the master controllers to 4 interactive robotic arms on the patient cart. The precisely controlled micro-movements of the Da Vinci instruments are enabled by the computer processors of the system. These dedicated processors perform millions of safety checks over the course of a procedure for enhanced surgical precision and control. Da Vinci EndoWrist instruments are designed with a unique wristed architecture that provides 7 degrees of freedom for a range of motion greater than even the human wrist. This proprietary design enables surgical maneuvers impossible with conventional laparoscopic tools. The system requires that every surgical maneuver is under the direct control of the surgeon. Redundant safety checks prevent autonomous movement of the instruments or the robotic arms. The Da Vinci S surgical system moves surgery forward with a new level of technical capability that enables minimally invasive surgery in complex procedures as never before. Da Vinci provides a streamlined
Bio-inspired robots. Bio-inspired robotics is about studying biological systems and looking for the mechanisms that may solve a problem in the engineering field. These type of robots were originally developed to build better support in the field of orthosis and prosthesis for human beings. It is a close collaboration between biologists and roboticists to interpret challenging topics in nature and to develop novel applications in robotics. Bionic hands. Bionic hands are controlled prostheses with electromyography. One such examples is robotic hand developed by Esper Bionics. Esper hand accurately detects muscle activity, recognizes situations, and predicts the grip that would fit. The more it is used, the faster and more precise it gets, and the more natural it feels. Military robots. Robots are an increasingly common part of military campaigns for defense, helping to keep soldiers safe and providing a tactical advantage in nearly any combat scenario. They differ from being autonomous robots or remote-controlled mobile robots and are designed for military applications, from transport to search and rescue and attack in any combats. Military robots are deployed for patrolling, combats and assisting in logistics. Space exploration robots. Also called as rovers, these robots are created to land on another planet, besides Earth, to find out information and to take samples. They can collect dust, rocks, and take pictures and communicate with the systems back on Earth to provide information for study. Some of the rovers are Spirit rover and Curiosity rover deployed on Mars exploration missions. Space manipulators. They are another kind of robots which are manipulators to perform repairs otherwise requiring spacewalks. The video shows Dextra, the Canadian robotic handyman on board the International Space Station. It has done several repair and maintenance jobs to date, as well as the robotic refueling mission technology demonstration, when it became the first robot to refuel a mock satellite in space. Autonomous vehicles. An autonomous vehicle is capable of sensing its environment and operating without human involvement autonomously without the need of a human passenger to take control of the vehicle at any time. Some of the examples include Uber, Waymo and Tesla's semi-truck. With various degrees of autonomy, they either operate under remote control by a human operator or autonomously by onboard computers. These vehicles are spread across transportation, military, entertainment, delivery purposes among few. Robots in utilities. Drones and semi-autonomous robots are helping keep workers safe by performing dangerous inspections that may otherwise put human workers at risk. Businesses use drones to inspect enormous structures such as buildings or grids. To reduce the risk of regular inspections, streamline the process, and minimize the needed equipment. Warehouse robots. Warehouse robots are robots employed to automate flows of work and increase productivity. They work independently or remotely operated or work alongside humans. These technologies work with full autonomy or in collaboration with operators to perform tasks such as moving products between 2 points, preparing orders, and storing products on racks. A few robots used for entertainment purposes. We can see Cosmo Robot, Misty Robot, Now Robot and DJI RoboMaster for playful purposes. Examples of NYU. NYU presents 3D printed robotic arm and a prosthetic arm. We have the shape-shifting robot, from NYU. Now that we have seen multiple robots, let us do an activity. When do you call something a robot? On the screen we can see a smartphone, a microwave, a smartwatch and an autonomous cyber truck. Here we can see a vending machine, a car washer and an elevator. When do you call something a robot? In this slide we can see an autonomous vacuum cleaner, a remotely operated racing car, a smart home system and a drone. When do you call something a robot? Thank you.